Okay, so the problem that we're going to look at today is an example of a integral that requires partial fractions. Student shared this with me, and we're going to take a crack at it. And I think a lot of students have been complaining or struggling with this kind of problem because it requires a lot of individual parts, all of which you know, but putting it all together and not making mistakes is kind of really tough. It kind of sucks. So let's try to break this down as best we can. So first off, looking at an integral like this, first thing you notice is that our conventional techniques like integration by part and u substitution are kind of failing us, right? For u substitution, you would hope to choose something in the denominator, but unfortunately the x squared here and the x squared here are the same power, so u substitution doesn't really get us anything. And as for integration by parts, I honestly haven't played with it myself, but just looking at it doesn't seem very promising whatsoever. It looks like a bad time, to be quite honest. Okay, so with this in mind, here's what we're going to do. The idea is that if we can just break this integral up into a sum of separate terms, each of which are easy to integrate, the hope is that integrating those terms won't be so bad. And that's exactly what we're going to do. So the way to rewrite this thing is always, you can look up a guide to partial fractions. I'm not going to go over the entire justification, but the entire idea is that you want to break it up into the linear term plus like a over the linear term plus bx plus c over the quadratic term. This is the general idea for whenever you have a linear and a quadratic. Again, if you want to, you can review this. I guarantee you probably learned this sometime in high school, but it definitely requires a refresher every now and then. But the idea behind this problem is, okay, let's just equate this thing in here to these two terms and then try to solve for a, b, and c. And then let's see what happens. So let's just go ahead and rewrite this. This is 2x squared minus 2 over 3x minus 2, x squared plus 4 equals a over 3x minus 2 plus bx plus c over x squared plus 4. Now the idea is, what if we just take through this entire thing and multiply by that denominator? Let's put it over, basically, let's just get rid of the denominators entirely. So we're multiplying through by 3x minus 2 on both sides and x squared plus 4 on both sides. So now what we get is just 2x squared minus 2 on the left-hand side is equal to a times x squared plus 4, right? Because the denominator is already 3x minus 2, so that cancels out this 3x minus 2, and what you're left over with is the quadratic. And then bx plus c times 3x minus 2. Okay, so far so good. So with this in mind, there's no, like, what do you call it? There's a lot of different ways to skin a cat here. And one of the easiest ways to make a first step of progress is noticing that although x squared plus 4 doesn't have, basically the idea is we're hoping to try to kill some of the terms here. We're trying to kill the b and the c terms so that if all we're left over with is a, we can easily solve for a. Remember that this equation has to be true for all values of x. So the idea is that if you can choose some value of x, like say maybe 2/3, to try to simplify some of these terms, it'll let you solve the leftover terms. And the reason I chose 2/3 was because I took a look at this thing here, and my aim is to make 3x minus 2 equal to 0. Right? So this is equal to 0 when x is equal to 2/3. So the idea is that if you went and plugged in x is equal to 2/3 now, you would notice that, well, let's literally just write it out. 2/3 squared minus 2 is equal to a times 2/3 squared plus 4. My handwriting's kind of messy. Plus b times 2/3 plus c times 3 times 2/3 minus 2. And what we notice is that this thing right here is 0. Right? This is 0. So this entire thing is 0. So now we can just ignore the b and the c. This is exactly what I was talking about earlier. You're trying to make the problem simpler. You try to kill the b and the c so you can just focus on a. So at this point, I'm not going to bore you with too much of the details here, but at this point, just solve for a. And I think what I got in my work was that, what does this become? Like 8/9 minus 2 is equal to a times, I think this turns into 40 over 9. And then a just becomes equal to like -1/4. Okay, so for these kinds of problems, the term that was originally linear, that had the linear denominator, that was the a, linear as in just x to the first power, tends to be the easiest to solve because you can force this thing to be 0 and isolate the a. But okay, so we've figured out what a is. Now we just need to figure out what b and c are. So at this point, let's just rewrite the equation above and just plug in 1/4 for a. So what we get is 2x squared minus 2 is equal to 1/4. Negative 1/4 x squared plus 4 plus bx plus c times 3x minus 2. All right. So at this point, we just want to rewrite, FOIL out the terms a little bit and group up coefficients of similar order of x. So this turns into minus 1/4 x squared minus 1 plus, what does this turn into? 3bx squared minus 2bx plus 3cx minus 2c. And what I'm going to go ahead and do is I'm going to group all the terms with b and c on the right-hand side and all the terms without b and c on the left-hand side. So I believe this turns into 9/4 x squared minus 1 is equal to 3b x squared minus 2bx plus 3cx minus 2c. And okay, what do we have here? At this point, I think I'm seeing that what you do at this point in these problems, what you do now is you take a look at all the x squared terms and realize that all of their coefficients have to match up. That means that 3b has got to be equal to 9/4. Similarly, for all the first power x terms, this is right. This stuff down here is basically 3c minus 2b times x. This stuff over here has got to be equal to whatever the x term on the other side is, which happens to be 0. 9/4 x squared plus 0x minus 1. Let's write it out more explicitly. But this 0 and 3c minus 2b have got to match each other, and this minus 2 and this minus 1, this minus 2c and this minus 1 have also got to match each other. I remember the very first time I learned this, it was a little bit confused, like, why do the coefficients have to match? And the reasoning for this would take a couple more minutes, and I think, might be more involved than it's worth. But the idea is that if every single one, if a, b, and c have to be chosen such that this equation is true, that it's actually equal for every single value of x, right? This is basically saying the right-hand side is going to form a parabola. And the left-hand side has got to form that exact same parabola, right? It's got to be that exact same parabola because for each value of x, the value of f of x has got to be equal to each other. That's the idea. So if this is sort of like, if this is like f1 of x and this is like f2 of x, we're saying that the two parabolas have got to be equal to each other, and the two parabolas are equal to each other if and only if each of their coefficients for each of the x squared, x, and constant terms are equal to each other. So let's just explicitly write this out. Because we're looking at the x squared terms first, this means that for the x squared terms, 9/4 has got to be equal to 3b. For the x terms, 0 has got to be equal to 3c minus 2b. And finally, for the constant terms, maybe I'll just write constant instead of 1 to make it clear, but -1 has got to be equal to minus 2c. And at this point, we just have two unknowns, b and c, and we have 3 equations. So we actually have more equations than we actually even need to solve this. So let's just take a look at whatever's easiest. It looks like the first equation will easily give us the value for b. That's just going to be 3/4. And the second equation, it looks like will give us c is equal to 1/2. And if you really want to, you could just use this equation for verification and plug things in to make sure that it comes out to be true. And in fact, it does. But at this point, we know the value for a, we know the value for b, and we know the value for c. Remember, a was equal to -1/4 from above. And we just plug that into whatever thing we had here, right? So remember, the original integral was 2x squared minus 2 over 3x minus 2, x squared plus 4. Now we're saying that that integral, just by pure algebra, we haven't done any calculus yet, is going to be equal to -1/4, 3x minus 2, plus 3/4. I'm just plugging a, b, and c into the expression we had above. plus 1/2 times x squared plus 4. So things are looking a little bit better, just a little bit better. We can break this down into a little bit simpler format by just rewriting the integral as minus a quarter 1 over 3x minus 2 right? And we can call that dx, and then we can split up the integrals so that, what's the next integral? It's going to be 3/4. We'll just write the 3/4 out front. X over x squared plus 4 plus 1/2 integral of 1 over x squared plus 4 dx. And at this point, things are looking pretty good. Things are not so bad at all, actually. What we notice is that this integral can be done. This is just going to be a natural log. You just have to make sure to use chain rule to properly account for the 3 out in front here. But yeah, these are all integrals that you should know how to do at this point. This one over here could be done by u to u pair, right? So if we take a look at u is equal to x squared plus 4, then du becomes 2x dx. And the numerator and denominator work out perfectly, right? The x dx you see up above here. It's going to work out nicely. Do the u substitution. Make sure to keep your calculations careful and clean. And then for this last one, it's just a little bit nasty because it involves an arctan. But the integral of 1 over x squared plus 4 can be rewritten as, if you pull the 4 out in front, this turns into an x over 2 squared plus 1. Right, I'm rewriting it this way just to make it very clear how the arctan comes in. But we know that the arctan of, we know that the integral of, how do I put this? Let's select u to be x over 2, so that du is dx over 2. Then this integral just turns into, I think it turns into something like just 1 over 4 u squared plus 1. And we know the integral of 1 over u squared plus 1. That's just an arctan. Arctan. Shoot. Right, so the integral of 1 over u squared plus 1 du is just equal to arctan of u. And at that point, I'll let you finish out the rest, right? Just make sure to be careful about your constants and all that. But so yeah, that's the idea. I hope this is helpful. Remember, just the idea is that's kind of a long problem and involves a lot of different pieces, but each one of these pieces is something you already know from calculus or from high school even. So yeah, stay careful and do your calculations very thoroughly.